Hi, everybody. Thank you for joining me at this late in the afternoon. Hopefully, we only have a couple more sessions before we can all head over to the happy hour boot crawl after party. I'm super happy to be here. Nice meeting you all. Today, I'm going to talk about how you can speed up your team by moving your development environments to Kubernetes. Um, my name is Ramiro. I am one of the founders and maintainers of Okteto. Okteto is a open source Apache 2.0 project. If you want to connect after the meeting, the presentation, talk about dev environments, dev experience, Kubernetes, startups, or anything in between, that's a QR code to my website because my name is really hard to spell. And in that website, you can find Twitter, Mastodon, LinkedIn, and other links. So, okay, we're here to learn together. So I'll go through some things. If you have any questions, I will leave some time at the end, but raise your hand, and I'll try to cover them as we go. I mean, the biggest benefit of being here in person is having an interactive session rather than just somebody talking as if we were on Zoom. And what I have to say, I'm super excited to be here in Tampa. I normally live in the Bay Area in Oakland. I am from Mexico, one of the few Latinos in tech. Born in Mexico, moved to the US, now work for Okteto from Oakland. It's really cool to be here. It's so much warmer and nicer for anybody who's local. Congrats, good choice. It is definitely a place I want to visit again. And thanks to Civo for organizing and picking up such a cool venue. So let's get into this, right? When we're building modern applications, what do we as developers care about? Well, we care about our source code, right? You need code. We care about our IDE, our configurations, our plugins, our extensions. We care about containers. We care about databases. We care about debuggers. We care about tests, dependencies, application configuration, infrastructure as code, security, network, infrastructure, and many more things. This is something that has been happening over the last 10, 15 years, how as applications become more complex, as we went from big monoliths to containers to microservices to cloud native applications, the need for in understanding all these components is just growing. And this is a challenge for all of us in the industry. It's a lot. And especially as you scale up teams, as you build organizations, expecting everybody in your team to be an expert in these 11 plus things, it's either unrealistic or it's possible, but at the expense of productivity, of talent, of specialization. So this is a topic that I'm fairly passionate about. This is one of the reasons why I started this open source project, and then a company is kind of work and see how, as developers, can we build a great dev experience for cloud native applications. And this is, I love this gift because this is what it feels like sometimes building cloud native applications. Like you are writing code, but you always feel like you're going uphill because there's all these other components. You think your code works, then you go to CI/CD, and then you discover something, or even worse, in production. And this is, for me, one of the biggest challenges that today affect teams. They affect productivity. They affect morale. And they make people really, like, going back to the previous session, feel like an imposter sometimes, that, hey, I can't do my job right. And as I was saying earlier, right, this is a problem that is affecting the entire industry. Like, one of the biggest issues here is that engineers are now spending hours just getting ready to, what I call getting ready to work. Somebody joins your team, or you go take a break and go back to work, and then setting up your local environment. In some places is fairly fast, Docker Compose up, but in a lot of these places, you have to get dependencies, data, components, all those 11, 12 things I show on the first slide, and each of them takes time, takes attention, takes focus, and creates this frustration that teams are having. And it's a topic that I've seen people talk about, like, just in this conference, there's like 4 or 5 different talks on this topic. So it's something we're all thinking about. Another challenge is that because we have so many dependencies, so many components, a lot of bugs are slipping to production because in most cases, development and production starts to look fairly different. Like, I've worked with teams where dev environments are running on Compose, on Docker Compose, and then production is running on AWS Lambdas or on Kubernetes. And this difference means that you effectively have 2 products, one on local machine, then the one in production, and they're so different. There's a lot of issues that you can only try in production, and that is not great. This is creating all these issues. Um, and what for me was kind of like the camel that broke the what's the straw that broke the camel back, and what drove me to start Okteto was you go to a company and then every developer has their own way of building a dev environment, and then forget about standardization, forget about policies, forget about not reinventing the wheel. Like you go to every dev box and everybody has a script with 15 different things and dot files and dependencies, and somebody's using Nix, and somebody's using Arcade, and somebody's using Minikube, and it becomes this hellish thing to support because nobody can help you. Like each dev environment is so unique that there's no way to get help. And then when somebody new joins your team, they're on their own. And then I've worked with companies, global banks, where it takes months before a developer can be effective because it's just so hard to kind of get started. And finally, and this is where everything ends up to, is a bad dev experience. It results on teams that stop innovating. They're only going for the sure thing, and they stop having fun when developing. And it's a hard job, but if you like it, then you do ambitious things, you do extraordinary stuff. But if you're not having fun, if you're not taking risks, if you don't feel safe to work, you go for the easy thing. You start building internal tools. You start like just fixing the bugs on the backlog and never pushing new features. And this is how companies or products lose to the competition. At the end of the day, for everybody who works in an engineering team, it's all about shipping value. And the quicker you ship value, the better your team gets at it, the higher the likelihood that you are gonna be successful. And this is the case on early stage startups, which is where I work right now, all the way to like the largest companies in the world. Like it's the same everywhere. So I'm here to talk about how cloud dev environments helps with this. And I always start with this question, right? We're building applications, cloud native applications that are meant to run on Kubernetes. Why are we not developing there? Why do we have to make this jump from local machine, local processes to Kubernetes? What if we do the same thing in both sides? And that's what I wanted to show you today. Cloud dev environments is this new paradigm in development. My company does this. There's many others. Loft, I have a list at the end, but there's all these other open source and commercial products. Loft, Civo had a presentation earlier today. Virtual Cluster is talking about this a couple of sessions after. It's a new trend where we are moving all these dev workloads into Kubernetes. Different ways of doing it, but what you want to accomplish is a single-click experience, a copy of production, an abstraction for developers not to have to be experts on Kubernetes and inference code. And finally, the ability to develop, debug, and write code in a way that is a production, what I call a production-like dev environment. Is something as close as possible and as close as practical to what production looks like. And this is what we, when we discuss about cloud dev environment, this is what we mean, is this ability to just move everything you run on your dev machine. And for some people, this means everything from the IDE. In our case, with our open source project, is from the code and going forward, and I'll show you in a second how that works. But this is the core idea, is replace this readmes, replace this local experience, this dev box, with something that is automated, that is defined as code, and that it creates the best abstraction you can for your team and for your needs. For me, this is where kind of like the key value of cloud dev environments is this is today the typical feedback loop that a developer building an application in Kubernetes has to go through. You have to write your code, you have to commit, you have to push to a branch, you have to wait for CI/CD to run and build some artifacts. And then if you're lucky, if you have something like a preview environments, you can see it there. I've worked for very large companies in the past where you have to wait all the way to release to be able to realistically see your changes running on a multi-microservice environment. And this, sadly, is the standard of the industry. Like, we're moving away from this, and I'm very happy that most people now understand how this is terrible. But this is still where we see most teams at. And this is what creates a lot of that frustration I was talking about. It's like, you have to go through all this cycle to realize that you had a typo in an environment variable, and that means that your observability is not flowing to Datadog. And that happened to a friend of mine in a very large streaming company. And it's absurd. And then you have to add days and days of work because it's such a long cycle. And that is what we're trying to fight by giving developers access to all this infrastructure as part of the inner loop. We want to go from this to something like this, where developers can write code, push it immediately to Kubernetes, get this very fast experience, be able to create, be able to validate, kind of like shift left as much as you can. And then once you're done, once you have a certain level of trust that you know things are going to work, then sure, commit, push, go through CI/CD, build your artifacts. There is value in all those things, of course, and then release. But my goal is that by the time you hit that release, you're not kind of like crossing your fingers and waiting for this new code path to execute. Like you should have the certainty that your code is going to work there. So enough slides. I'm going to show you how this works. This is the application we use for some of our demos. We call it the boating app. If you've been around long enough, you've probably seen this app in the Docker days. Part of my team used to be a Docker, and they built that app, and then we kind of stole it. It's your typical microservice-based application. It lets you boat on a favorite item, and then you see the results on the other side. And it has 3 services. It's polyglot, just for fun. Has Java. It's a Spring service to take the boats. It's a Go worker that picks up the boats from a Kafka queue, does some parsing, puts it on a Postgres database, and then there's a node service using Express that is showing the results, streaming them through a WebSocket to your browser. Just overly engineered, but as a way to show people all these different patterns that you have with cloud-native applications: async, sync, use, databases, and polyglot apps, which is something else that we're seeing a lot out there. And everything is on a monorepo, because why not? And the whole thing it's online. I'll share the link at the end, but if you go to github.com/okteto/microservices demo, or just go to demo, you'll see it there if you want to try this. Everything I'm going to show you today works with our open source product. We also have a free SaaS. If you want to try that out later, or for those of you watching the recording, you can see it there. So, enough of the slides. We're going to go through the demo. So, first things first. This is the CLI. It's an Apache 2.0 open source project. It's a binary. It's a Go binary. Runs on ARM, Intel, Windows, Linux, Mac. If you like it, please star it, subscribe, open issues, any of those things. It's a binary that you download. And once you have that binary on your local machine, you run Okteto deploy or Okteto up to launch your dev environment and to synchronize your code. Today for the demo, we also have a commercial product. I'm going to use that because it's more visual. Like it has a UI. That's one of the biggest differences. But everything I'm showing you here, you can do with the open source project. And our commercial product is free for small teams as well. But this is what a dev environment looks like. So I'm going to go back to the repo. And the way Okteto works is you have a YAML file. And this is the wrong YAML file. Here we go. You have a YAML file where you specify how to build your application, which is which artifacts you want to build on demand, or which ones you want to pull from any artifact repository you might have, Artifactory, Docker Hub, any of them. You tell Okteto how to deploy your application. In this case, we're using Helm. And then finally, you tell Okteto how you want to develop your application. The goal here is 2 main things. One is, now I have this representation on my repository of what my dev environment looks like. This means that anybody that clones this repository and deploys our dev environment is going to get the same thing. Same images, same dependencies, same scripts. The other thing we want to accomplish with this is help you use the same artifacts you're using in production. Like in this case, we're using Helm. There's no Docker but Compose version. There are some changes, of course. You might use a smaller size of nodes. If you're using a database, maybe you don't need the full production deployment of your data. But the idea here is to reduce that skew as much as possible, as much as it's practical between dev and prod. And finally, dev is where you overwrite things that you care about during development that you're not going to care about during production. For example, code synchronization, hot reloading, remote debugging, injecting environment variables because you have a token for an NPM private instance, stuff like that. So once you have this, there's 2 commands, Okteto deploy, Okteto up. I'm going to go here. This is VS Code. I have everything here. So the command is Okteto deploy. The idea behind Okteto is you have a shared cluster, and you're going to give every developer a namespace. That way, any developer can have as many dev environments as they want, different branches, the same branch, different states, and because they run on Kubernetes, they're going to be able to share them, scale them to Civo, destroy them when they're done, all that stuff, which typically you can do on your local machine. So this case, I have a namespace with my name, Ramiro, and then this will create a namespace if needed, and then I just do Okteto deploy. Okteto deploy will read the Okteto manifest, will build my images. You can configure Okteto to use BuildKit, to use Canico, to use your local Docker daemon. In this case, it's configured to use a remote build service that's running on my cluster, so that's it's a bit faster. You can see it's downloading from Maven, but nothing is being downloaded on my local machine. Another big advantage of GitHub environment. But because I'm going to do this cooking show style, I have another namespace, navigate for in, and here you can see that I have my dev environment up and running. What I showed you before, I have Kafka, Postgres, and my three services, and everything was deployed by just running the deploy command. So if we look here, I have some endpoints already, SSL, the whole thing end to end. So I can go here, and let me just copy this. Go here, and you can see the application running end to end. This looks simple, but this is this entire architecture that we show here. Voting and result. This is the voting. This case is like which conference do you prefer, Navigate or all the other ones? Well, we're Navigate. We're here. They're buying drinks, so let's give them some votes. And you can vote here. And what I'm doing here is I'm validating that my code works end to end. When I click on this button, this is making a post request to a Spring service that is talking to a Kafka queue, that is talking to my worker process, that is talking to a database. So you get this end-to-end verification that your code works. So stage one, I have this. You look here, visual representation of the same thing. You can see I have multiple environments, right? Which means I could keep different branches, which means that I could take this link and send it to any of you. Like any of you, pull off your phone, you can go here, go to this link, and you can vote. And this is where we've seen all these really interesting new mechanics happening of sharing dev environments, of sharing your process as you write your code rather than once you're done. Like for me, one of my goals for the next couple of years is I'm trying to sell people on the idea that the commit should no longer be the unit of like sharing. Like why do you have to wait until your code is committed, until you have a PR to share your progress? So step one, I have the environment up and running. I can destroy it, whatever I want. Step two, I'm going to work on it. And that's where the second aspect of this idea, which is Okteto up, comes to picture. Okteto up is when you're ready to develop. Okteto up is going to read this manifest I showed you before. It's going to ask you which service are you going to be developing on. This is another thing where we are very opinionated. We believe that you should work on one service at a time. You can run as many Okteto ops as you want. But one of our core ideas here is stop burdening every developer with this huge cognitive load. Like you don't have to think. We have customers with like 100 microservices. You don't have to have every developer think 100 microservices. You want them to think of what is the task at hand. In this case, we're going to change the voting from Navigate, and we're going to put some other name, right? So I want to work on the voting service. I click vote. Everything else will stay the way it is. But Okteto is going to apply all these overrides on vote. It's going to create an SSH tunnel for me, so I can do things like remote debugging, file synchronization, all those things. So in this case, you see there, synchronizing my files, it's starting a port forward, and in a moment you'll see it's going to start a command. In this case, I got the wrong one. Hold on. Okteto down. Code. I want to use the other one because this one is a Java one. I want to do the result because that's Node and it's a lot easier. Result. But you can see how easy it is to switch from one service to another, whether it's Java, Node. It's completely transparent. There's images already being built. One thing you can do with Okteto is you can define a container image just for development. In this case, my container image has the entire Node runtime, while my production image only has the dependencies I need. This one has NodeMon. It has the debugger pre-installed, all those things. So here we are. We are on results. So if I go here, I'm going to go to the other service, result. And you'll see it's there. It's still running end to end. I go here. I apply more boats. I go here. You'll see it's changing because it's syncing live. I'm testing, again, the entire flow of things on Kubernetes. Nothing is running on my local machine. No process. I don't have this version of Node. None of those things. But I can go here. And, hey, let's make a change. Navigate, and instead of others, let's do some. I'll get in trouble here, but let's say reinvent. Because reinvent is a whole different type of conference. You know, what do you prefer, navigate or reinvent? I go back here, I refresh, navigate and reinvent. I don't have to read my containers. I don't have to think in terms of like redeploy containers. I'm just thinking in terms of code. And it's a very simple example, but this becomes, you know, the standard of development for a lot of the teams using these concepts. Is it's so much faster. And which for me is actually one of my favorite things here is I can even attach a debugger. I can put it here. Debug. You'll see it in a second, I hope it works. Live demos. Maybe. And when you actually go through the result, it will attach. You can do step by step. You no longer have to do println-based development, which is what I've been doing for the last 10 years. And this is an example of this idea of like end-to-end, everything on Kubernetes. You're not running anything locally. And the same thing happens. This is IntelliJ, this is on Java. This is completely independent of IDE stack. Same thing as before. I'm going to do boat in this case. Boat will synchronize with the boating service that is a Spring service on Java. In this case, I'm using IntelliJ because I want to show you how well it integrates. Because at the end of the day, what we're building here is a development experience. It has to be easy. It has to be flexible. One of the things I learned from the very early days of me working on developer tools and open source is if your tool, if your experience doesn't align with what the developers are already doing, that's an uphill battle. And we go back to that GIF of the guy pushing up the loading ball, that beach ball. It becomes really tough. So in this case, I'm using IntelliJ, I'm using Maven, I'm not reinventing the wheel. You can use whatever tool, Helm, customize, Docker Compose. It's entirely up to you. But just as before, in this case, we have it here. It's still running end to end. Same thing. I can attach a debugger, and you'll see that it's connecting. It's here. I could put a breakpoint on, let's see, on here when you're posting, and then you see it's connected. And then when I post a boat, it breaks. And you can see the context. You can make any changes. And the one service was in Java and in Node. This is in Java. I don't have the JDK. I don't have any of these things locally because everything is coming from Kubernetes. Go ahead. That is a great question. Does it require a custom run config? So what we're doing here is we're leveraging remote debugging capabilities. So the JVM has remote development capabilities. So if you go, let me see if I remember where it is. If you go to the settings, let's go here and modify, maybe it's here. Oop. I always forget with IntelliJ where it is. This one? Oh yeah. Here, right, yeah, you're right. Edit. All we're telling them is, hey, localhost and this port. And then in Okteto, if I go back to the YAML, you see that Okteto, when I define my dev environment, I told him that for the boat service, I want to forward port 5005. Same thing with Go. It's a different branch, but like here for Go. This one is using Delph, so it's 2345. And this is using what is now becoming a standard, which is every major programming language now has an interface for remote, attaching a remote debugger. And this is like, in my opinion, is like the easiest way because you don't have to install any components in the cluster. One thing that Okteto does that is very different, and for us was also a key design decision, was anybody who has access to a Kubernetes cluster can run this tool. You don't need to be an admin. You need to modify the network. If you're going to install the full thing, like you get the nice UI and admin user, yeah, that's a different story. You need an admin. It's a Helm chart. You put it. But for this flow of like Okteto up, develop, when you're done Okteto down. That's all you need. So this is a quick example of what you can do. We have a lot of samples there. If you go to Okteto/demo, you'll see on every programming language, we keep a list of dev environments that you can just consume here for some programming languages that we have experience with: Golang, JDK, Node, PHP, Python, Ruby, Rust, .NET, because I used to work for Microsoft, so I have a soft spot in my heart for .NET. But they're all there, and what you can see is that all of them are like fairly simple Docker files. And this is really all you need to use Okteto, is you define a Docker file. We always encourage all of our users to build their own so that you can customize and put the tools you care about. Some of our users in large corporations, they have like their own custom tooling. They're not using Maven. They have something else because it needs to go through some specific hoops, or they want to use certain proxy. You can put all that in a container, and then when you define your dev environment here, in this case, going back to our file, in this case, I'm just telling Okteto, hey, use this dev image that I'm building. And if you go up here and you see there is an image called build dev, and you go here and there's dev, you see that we're using the same Docker file, a different target. There's all these patterns that are emerging from our community. It's not really on us. But the idea is this, is microservice aware dev environment, use containers, use your existing artifacts, your existing scripts, and enable things like debugging and hot reloading, because we don't want developers to have to build containers every time they want to do a change. And then you can take this, go ahead.
Does that dev target require you to install any dependencies that are different from target that's in production that allows remote debugging?
So this target is not an architecture. This is a target in Docker for multi-stage builds. So it's pretty much, this is the pattern I like to use for this examples is you have a dev stage, which is the same one you use to build on CI, and then you have the production stage, which is where you only have your binary. I like this pattern a lot because this means you're also using the same container and the same description on dev, CI, and production.
Is this where you're adding the remote debugging capabilities?
Mm-hmm. So Okteto will inject the file synchronization and the remote bash, all those things, Okteto injects. If you want to do, for instance, remote debugging, and this is a good example. Here, we are installing Delve, which is Golang's debugger on the base image. In other cases, like in Node, and let's see, where is the Node one? This result. In this case, we're just using the, it's very old, but we're using the Slim 12, because that one has all the tools we need. That one has NodeMon and the debugger. In the case of Java, same thing, like JDK, you have the image with the JDK, and you install the Spring components, and that brings the debugger with you. One thing we did, and that's where like I really see the value of containers as a dev tool, is because container is the interface. That means that you can use any framework you want, any tools you want. Typically what we see with large teams is they start to build their own templates and their own base images. Like you want everybody in your team to use the same version of the JDK, or to be in the same version of Node, because you don't want some random developer like me to use a 5-year-old image of Node. You want them to use the latest, vetted. That is part of what we've seen as this really cool emerging pattern is now that everything is in infra code, also for dev environments. You saw the demo. I didn't run a single build or Kubernetes command. I ran Okteto deploy, Okteto up. In our team internally, we use Okteto to develop, and this means that our front-end devs who are really good at React and those things, they don't have to be aware of Kubernetes. They don't have to deal with like pods and those things, but they can still develop on an environment that is running Kubernetes, because our application is meant to run on Kubernetes. And even in the front end, we always find things that if we had not been running on Kubernetes, they would have gone on the production. Like how you do secrets, how do you do environment variables, how do you call the API? Is it localhost, or is it like the full URL, HTTPS issues, certificates, all that stuff?
So does Okteto provide this Docker file with multi-stage Docker build?
We give a sample, yeah, and then this is something you can build. This is a standard Docker. Like we in our commercial product, we use BuildKit to build the container, so we can have a fork of BuildKit optimized for dev use cases that runs on your cluster, and it's completely compatible with anything that's Docker official. The same thing, we also include a container registry to push the dev images as you build them, and it's a standard OCI compliant registry. You can bring your own if you don't want to use like some of our customers prefer to use a local build kit or Docker because it's faster because they prefer that caching mechanism. You set up a variable and you tell Okteto, hey, use my local build service rather than a remote. And the idea, like most dev tools, right? You have to think in terms of composability and go what goes there. But this is, whether it's Okteto, and I'll give you some more examples, like whether it's Okteto or something else. I really recommend everybody who's like building on a dev team or you're building something cloud native to start looking into this new paradigm of cloud dev environments. There's all these different tools, different opinions, different ways of doing this. It's definitely like we've seen it with teams of everything from like a few developers to like thousands of developers in our community. It is life changing. Like the performance, the usability, the self-service you open, it's really cool. So I just to finish, and everything I'll share at the end. Everything it's there. It's open source if you want to try it out. But so the question is, should I move my dev environments to Kubernetes? I hope that by now I kind of sold you like a maybe. I don't know if you're ready to say yes, but at least like, hey, let me know more about this. And we have this questionnaire. It's kind of a jest, but there's some truth behind this. Are you developing an application that is meant to run in Kubernetes? Do you or are you planning to install Minikube, K3s, or any of those wonderful things on every developer's machine? Do you have to teach every developer in your organization to know how to use Kubernetes? Your application plus Minikube plus Docker Desktop plus Slack or Teams or Meet or any of those, can you run the whole thing on your laptop, like comfortably? And do you want to reduce the difference between dev, staging, or production? Do you value the time of your developers? Do you pay them to kind of tinker with Minikube, or do you pay them to ship value for your customers? If the answer is yes to at least one of those, you should definitely move your dev environment to Kubernetes, or at least look at it, because definitely there's a lot of things you can gain by doing that. And what's in it? Why would I do it? I give you a technical demo, but now I'm gonna kind of change my hat to like the PM product hat and sell you on the ROI of cloud dev environments. Well, they're magical. It just works, and when it just works, like you see a team enabled. But in reality, now you're able to get a full dev environment up and running in seconds. And that alone, like thinking in terms of onboarding, in terms of like working in different projects, if you work for a consulting company and you have multiple clients, it's a great pattern. If you're like changing branches, if you're doing PRs, it's also really useful. You're gonna give your laptop a break because you're running most of the workloads on your cluster. And something I didn't show here, but we also have this hybrid mode where you could be running all your services locally and then run all the heavy databases on your cluster if you're running something like Elasticsearch, Redis, Postgres, any of those things. You could also enable a hybrid where some things run in Kubernetes, other runs locally, so you don't have to carry this weight. Where are you getting your data from? All that stuff is something that Okteto or any of the other players in the space can help you with. Your dev environment is going to look a lot like production because it's running on Kubernetes. You're going to be able to run every other thing. Like Victor from Upbound and I gave a talk about this topic at KubeCon at Rejects, how you can use Crossplane and Okteto together to build these dev environments that include containers, AWS databases, infra somewhere else. The same thing you can do if you're using something like OPA, Kubescape. Like all these tools speak Kubernetes, which means you can compose them together to give dev environments that are like cloud native and that they look like production. Again, it's all about like giving your developers the chance to use all these tools to try all these things before they get to production. Everything in your team will get a faster onboarding, and I cannot stress this enough. I've been meeting, because of what we do, a lot of like CTOs, big engineering founders of like very large companies, and the onboarding time, the faster that is, the faster your team is going to be. There's a correlation, like teams that care about onboarding time, they tend to care about the full dev experience. They have access to better talent. Like when you join a team and they have a great onboarding experience, you feel better. Like one of people in the community launched Darkly, a very famous company in the feature flex space. Their goal is like every engineer needs to deploy to production on their first week. And they measure this and they're like tracking it week after week. If it takes you a couple of weeks to provision an environment, there's no way you can hit this goal. But if you can give your developers one command, one click, and a couple of hours later, you have your own copy of dev environment ready for you to tinker, that changes the game consistently. And to me, this is like, as you know, my hat as a founder, as a person that runs an engineering team, this is like fundamental. Collaboration, I was saying this earlier, right? You can collaborate as soon as you write code. I show you a demo where I changed a line of code. I see the results. That URL was live. Anybody who has access to my cluster could see that URL, could interact with it. This is great also when you start involving other personas in your reviews, PMs, stakeholders, customers, your product team. PRs typically are just for developers because you only see the code. But if I can send you a link that is live with my changes at any time, I can put that on a Jira ticket or Linear or Monday or whatever you're using, and then anybody that's involved with that release can go click and see it. And that is also something that becomes really valuable as you scale up organizations. And you may even save on infra and overhead, because rather than having one cluster per developer or 1,000 Minikube instances that you have to hire someone to maintain and train and troubleshoot, you have a few dev clusters, and you give every developer one or as many namespaces as possible. Kubernetes is really good at running workloads at scale. And Beam packing for dev environments is relatively easy. In our SaaS, we have hundreds of clusters, and we host 20, 30, 40,000 developers. And it's just like, it scales really well. Another advantage, because having to troubleshoot, again, a dev environment that's local, it's not just the infra cost. It's not just the cloud bill versus how much like the latest MacBook Pro is going to cost you. Is you have to train somebody to go and call them and see, okay, why is Minikube not starting? And you have a front-end dev that has no clue and no inclination to learn about this Kubernetes thing. They're just like, hey, I can't run. Help fix it for me. Like, all of these costs adds up. It's not just the infra versus hardware. It's something to think about as well. It's not the main reason and it should not be like the driver, but it's a nice side effect that we've seen in our community as more and more teams and companies adopt some of these concepts. So just to wrap it up, how do I get started? Like, let's say that I did a good job and you're sold and like, yes, I want this for my team. What do I do now? Well, these 4 questions are good to kind of like ask yourselves, because it's going to help you figure out what kind of dev environment are you looking for. Do you care about the IDE? I don't care. I prefer to give my teams the flexibility to run their IDE. You saw my demo. I'm switching from VS Code to IntelliJ to BIM to Emacs, any of these things. Other teams prefer Cloud IDE, like Gitpod, Coder, VS Code code spaces. That is a decision that you have to make, and you have to figure out the trade-offs. How much do you care about parity between production and development? We have members of our community that they want to go all the way, which means the same class of infra, same configuration, same databases, RDS everywhere. It's your call to make. Some people prefer a faster, slimmer environment where everything is using things like local stack and container-based services. Others want to deploy the full thing. Do you want to include all dependencies on your dev environment? If you have 100 microservices, do you want to run them all per developer? Some companies say, yes, I want to do this. It's more effective. And we've seen it at scale. The largest usage of cloud dev environments I've seen, every engineer was deploying 150 microservices. I agree. I think that's crazy. But for some cases, the decision is never that clear. Like, you are leading legacy code. You have old stuff. And it's possible. And it works really well. This company has 1,000 developers working like that. And they have a few nodes. So again, for each of us to answer this question. And finally, and this is one that I also gave a few talks on this, very important, is what is your strategy around developers and data? Data is a fundamental part of cloud dev environments. Do not give your developers access to production, please. There's been too many issues about this, and we all know. But as you move to the world of cloud dev environments, there are tools that can help you, whether you are of the school of like, I want synthetic data, like Tonic, or no, I want real data that is cleaned up, like Privacy Dynamics. It's up to you, but it's something else to think about as you build your strategy around cloud dev environments, because what ends up happening is that cloud dev environments become a core part of your developer experience strategy. It's not the only thing that matters, right? But it becomes a very substantial part. And as developers see the value of tools like this, they start using them a lot more. And then you see teams that they develop exclusively on cloud environments, and they no longer care about the local experience. Not everybody does that. It depends on the team. It depends on a lot of things. but it's something I've seen happen multiple times at very well-known companies. So there's a few projects in the space. You know, I show you Okteto today because I'm a maintainer. I started that project, so I'm biased, of course. But there's many others. Dead Space, very similar to Okteto. It's part of the CNCF sandbox. DevBox from Jetpack, which uses Nix and has a different approach, but also automates deployments. Okteto CLI, Telepresence, more focused on like how you kind of like trick the network to redirect things to you. Scaffold, which is probably the granddaddy of them all. I bundle it together. I have a strong opinions on Scaffold. I don't like having to build things at all. I love the change my code, see the results, but if you prefer the more traditional build, deploy, automation, Scaffold is great. There's other there. There's a lot more, but these are the 5 that I've used and I like the most. But there's many, and you know, every few months there's more because there's way too many different ways of developing code. You're never going to find the one through for everybody, as much as I wish. From the commercial side, there's also like solutions that will give you like an end-to-end solution. Git was one of them. Jetpack, Loft, Rich from Loft is going to give a talk on virtual cluster, I think right after this one or 2 more. You should check it out because it's a really cool project. Okteto, as I show you, we have an open source product, but also an end-to-end commercial solution. And there's more. This morning was a talk by Francis from Code Zero, another commercial solution. Check it out. That's why those four questions I put at the beginning are important, because you have to figure those out, and then you can pick which one is best for you. It's a new environment. Dev environments is a new ecosystem. There's a lot of innovation in the space, so you have to pick whatever works best for you. If it's Okteto, happy to talk. If not, like all of them have like growing open source communities, Discords, Slacks. They are in every conference. I'm super excited to see how dev experience and dev environments are now becoming a topic at every conference. Everything from DevOps all the way to reinvent. It matters a lot. Like as we grow, as our applications become more complex, all of us need to solve this problem one way or another. We can no longer depend on every developer having a makefile and a README and a dev.sh. Those it's not effective. You can do it, but you're gonna pay with effectiveness. And finally, if you're thinking of implementing this, I know that for most of us, it's all about building. If you can help it, don't build it. Like most companies don't benefit from building their own cloud dev environment, so think about it. We put together a guide there. I did a webinar with our friends from Replicated last week on this. Just as an unbiased skin is like, it's hard to build these things, and if you want to build a great experience, find a good partner. Whether it's open source or commercial, I would recommend against starting your own. But thank you. If you like this, please like and subscribe. And you have my QR code if you want to chat. I'll be around until tomorrow. Any final questions? I know we're over. But I don't think you need them anymore.
What do you suggest if the dev cluster is down or being under maintenance? What would a developer do in that case?
That is kind of an edge case, and I think you still need a local experience. I think what you should do is, just like any other production service, track an SLA, have more than one dev cluster. What we've seen happens with this, it's kind of like CI, right? It becomes it's an internal production service. So definitely like treating it as with the same degree of protection and care as you do at your production service is very important. Whether you want to invest on a local solution or not is one of those decisions that you have to make. I don't think it's worth it because sure, that might happen and your cluster might be down. But then you have to keep this dual solution forever, which means that your code is going to have to make all these assumptions, if dev, if local. So it's like, hey, what I've seen and what we recommend is, hey, yeah, if you have a few hours of downtime, deal with it. It's the same thing that if you depend on a cloud service, AWS is down twice per year. Are you going to build your own cloud service? No, you just like suck it up kind of thing. But it's very, every team has its own opinion on this. And just finally, we're hiring. So if anybody cares about this topic, okteto.com and check it out. But thank you very much.